Hello everyone, myself Sandhya Palmur. In last video, we studied how to obtain the Fourier expansion if the function is even and odd. Now, in this video, we will see if the function is neither even nor odd. These are the some values and formulae which is required to obtain the Fourier expansion. Type 3, for the interval minus L to L, we will see example f of x equal to e raised to x for minus pi to pi. Answer, given interval is minus pi to pi, as this is start from negative to positive, so it is compulsory to check whether the given function is even or odd or neither even nor odd. Thus, replacing x by minus x, we see that f of minus x equal to e raised to minus x, which is not equal to f of x. Here we cannot obtain e raised to x, that is same function. Hence, the given example is not even. Also, if we write minus f of x equal to minus e raised to x, so this is also not equal to the given example, which is not same. Hence, this exponential function is neither even nor odd. Thus, we calculate the three Fourier coefficients a0, an and bn. The Fourier series formula is given as a0 by 2 plus summation an cos n pi x l plus summation bn sin n pi x upon l. Thus, f of x equal to a0 by 2 plus summation an, substitute here the value of l as pi. Thus, cos n pi x upon pi plus summation bn sin n pi x upon pi. This pi will get cancelled. Thus, we get f of x equal to a0 by 2 plus summation an cos nx plus summation bn sin nx. Now, first Fourier coefficient, the formula is given as a0 equal to 1 upon l integration minus l to l f of x dx. Here, the integrand is given as f of x equal to e raised to x. So, substitute here and l equal to pi. So, 1 upon pi, write on outside the integration. E raised to, the integration of e raised to x is e raised to x. Substituting upper limit and lower limit, we get 1 upon pi in bracket e raised to pi minus e raised to minus pi. Since we know e raised to pi minus e raised to minus pi divided by 2, which is equal to sine hyperbolic pi. Thus, substituting value, we get a0 equal to 1 upon pi 2 times sine hyperbolic pi. Now, next Fourier coefficient an equal to 1 upon l integration minus l to l f of x cos n pi x upon l dx. Here l equal to pi and substitute here f of x equal to e raised to x. This is a special case. Here we will use the special formula for the exponential and trigonometric, which is given as, this is standard formula, integration of e raised to x into cos bx dx, which is given as e raised to x divided by a square plus b square in bracket a cos bx plus b into sin bx. This is the standard formula for the exponential and trigonometric function. You have to remember here a equal to 1, e raised to ax, so coefficient of x is 1, therefore a equal to 1, and here b equal to n, that is cos nx and cos bx. So comparing, we get a equal to 1 and b equal to n. So directly use this formula. 1 upon pi keep as it is, and integration of this term can be obtained by using this formula. E raised to x, that is e raised to x, divided by a square plus b square, that is 1 square plus n square, in bracket, since a equal to 1, so 1 into cos nx plus b equal to n, therefore n into sin nx. Now limits minus pi to pi. So applying formula, next step is substitute upper limit minus lower limit. Therefore, instead of x, upper limit, that is e raised to pi divided by 1 square plus n square in bracket cos n pi plus n into sin n pi. This is the first two terms for the upper limit. Now minus e raised to, instead of x, minus pi divided by 1 square plus n square in bracket cos n pi, since cos minus theta equal to cos theta, therefore cos in bracket minus n pi is cos n pi minus n into sin n pi. Since sin minus n pi is minus sin n pi, so this plus becomes minus, since sin minus theta equal to minus sin theta. So first find the integration, substitute the limits. Now revalue this answer. Thus we get 1 upon pi e raised to pi divided by 1 square plus n square. Cos n pi equal to minus 1 raised to n. We know sin n pi is a 0, so this term is 0. Minus e raised to minus pi divided by 1 square plus n square. Cos n pi is minus 1 raised to n. Sin n pi is 0. So taking common this minus 1 raised to n outside, we get minus 1 raised to n divided by pi in bracket 1 square plus n square in bracket e raised to pi minus e raised to minus pi. And we know e raised to pi minus e raised to minus pi, this is what? Divided by 2, that is sine hyperbolic pi. So the value of this term is 2 times sine hyperbolic pi. Substituting here, we get this value for an. Now next Fourier coefficient, bn equal to 1 upon L minus L to L f of x sin n pi x upon L dx. Put L equal to pi and f of x equal to e raised to x. So this is a standard formula. If exponential and trigonometric function sin present, e raised to ax divided by a square plus a square, a sin bx minus b cos bx. If integrand sin cos present, here plus present. If integrand sin present, then in formula minus sign. So comparing, we get a equal to 1 and b equal to n. So applying this formula, we get e raised to x divided by 1 square plus n square. Here a is 1, so sin nx since b equal to n minus b equal to n, so n into cos nx, and limits minus pi to pi. Now we substitute upper limit minus lower limit. So when x equal to pi, we get e raised to pi divided by 1 square plus n square sin n pi minus n into cos pi. So these are the first two terms while substituting upper limit. Now minus lower limit, x equal to minus pi. So e raised to minus pi divided by 1 square plus n square. In bracket, we know sin minus theta is minus sin theta. Thus sin minus n pi is minus sin n pi minus n into cos n pi, since cos minus theta equal to cos theta. Thus we get 1 upon pi e raised to pi divided by 1 square plus n square. Sin n pi is a 0, minus n as it is, cos n pi is minus 1 raised to n, minus next term e raised to minus pi divided by 1 square plus n square. In this term sin n pi present, so value is 0 minus n into minus 1 raised to n. Now next step, minus n into minus 1 raised to n. Take this term common and 1 square plus n square. Thus we get e raised to pi minus e raised to minus pi. This minus n into minus 1 raised to n, take outside this bracket. Thus substituting again the value for e raised to pi minus e raised to minus pi, which is equal to 2 times sine hyperbolic y. Thus the final Fourier series formula is f of x equal to a0 by 2 plus summation an cos nx plus summation bn sin nx. Substitute here the value for these three Fourier coefficients. We have a0 equal to this 2 by pi sine hyperbolic pi plus summation, the value for an is this term into cos nx plus summation, the value for this bn is, which is obtained here, substitute in this term the into sin nx. So this is the required final answer, the Fourier expansion of e raised to x. Thank you.